Okay, everybody is here for the AI for Sustainability and Other Railroad Environmental Applications. Okay, perfect. My name is Jason.smeak. Welcome to the session today. I see a couple of familiar faces, so really appreciate your time. We're going to cover a safety briefing real quickly. We are in 101 FG Meeting Room in Minneapolis Convention Center, 1301 2nd Avenue South, Minneapolis, Minnesota. There are no planned emergency drills for today. Should an emergency occur, we will exit through the doors you entered, proceed to the right, taking a right at the large hall, exiting the building through the glass doors and rallying across the street in the church plaza. In the event of an emergency, dial 2013 on the beige house phone. There's actually one here outside of the doors to the right. You'll notice there's like a little vending machine, a white vending machine there. It's also next to the AED, which is located there as well. Anybody certified to perform CPR? Can you raise your hands? Okay, perfect. We have a couple here. Great. In the event of an active shooter, we will practice run, hide, and fight. If safe to do so, we will exit as previously stated. If not, we will barricade the doors and shelter in place. When entering, exiting, or walking about the room, please take care to look for any trip hazards. If you leave the convention center, please remove your badge. If you see something, say something. And then if anyone here requires any emergency evacuation assistance, please make yourself known to a staff member. We're excited to have you today. There is information on how to complete an evaluation in the mobile app. This is accessible through the convention mobile app using your smartphone or tablet. And go to the education button and select this session, and then you can tap there to provide a session evaluation at the bottom of that screen. Okay, so we'll go ahead and get started. Perfect. So today we're going to talk about AI for sustainability and other railroad environmental applications. I work for AECOM and happy here to help present here this topic, which is a very exciting one. Really the space of AI and the practical applications in the railroad space that have a positive impact to sustainability, to the environment, to our workforces, resiliency, and also compliance. And we actually have a great group of people today to talk to you about practical use cases in the real world of AI in this space. We'll start with some introductions, move into some basics around AI for freight rail professionals, share how AI can positively impact freight rail environmental performance, and roll into these three great use cases of AI, and end with a panel Q&A to dive a bit deeper into the AI theme and then entertain some questions as well from the audience. I'm joined here today by my fellow ASLRRA Environmental Committee member and Committee Secretary Peter.scholtens, President and Sales of Integrity Rail Products, longtime industrial rail technology leader Simon Davidoff, founder and CEO of Grand Crew Consulting. We have Dustin Bullard, a past radar electrical technician and longtime railroader, now CEO of Positive Train Control Services, and Dan DeVoe, Director of Marketing at Railroad Technology Services vendor RailState. So it is probably helpful to set some basic understanding about the familiarities and maturity levels in this room with AI. By a show of hands, how many people have used AI in their personal lives in some way? So maybe 70%, maybe a little bit more. How many people use it for work-specific purposes within their workplace? Okay, so a little bit maybe about half or a little bit less. It's interesting. In October 2025, Pew Research Center reported that approximately 1 in 5 Americans were using AI for work, but this usage was much higher for casual personal queries. Studies such as Epoch AI just published this past week say it's about half of Americans use AI for work. So this is obviously quickly evolving in the space. AI was first coined in 1955 when research was just beginning around how to think about machines and machines acting in a more intelligent manner. This has since evolved into a much more evolving and encompassing definition, really thinking about fields of computer and data science that are focused on building machines with human intelligence to perform tasks like learning, reasoning, problem solving, perception, and language understanding. One can think of AI in two different ways, thinking about the field and also the resulting AI systems or models that result. Though we are interacting with the field of AI, we often are going to or utilizing specific AI models, think ChatGPT or other types of applications of AI in the field. Today, it's an interdisciplinary field combining mathematics, statistics, cognitive science, and computers to solve complex problems using very large data sets and high-performance computers. And really, the latest developments in generative AI have just recently pushed AI into the forefront of all of our thinking, including here in the industry. So it's probably useful to talk about what AI is and what AI is not to clarify some of the misperceptions about the space. As with any high hype technology adoption curve, there are many misconceptions as to what AI is. So at its core, artificial intelligence is a system that takes on information or data, compares it against known patterns or logic, and then produces a useful output. You can think of AI as a tool that humans have built first and foremost. Outputs could be a recommendation, a prediction, a ranked list of likely causes, a guided troubleshooting path. Could really serve as a decision aid for many industries. There are also many different types of applications of AI, and so you can imagine from processing images to understanding human language. Therefore, there's a great power in the collective data present now in the internet and what we can do with it, or within walled-off private data sets, such as those you have in your own corporation. So let's talk about what AI is not. Some talk of AI as being science fiction. It's certainly not that, right? It's here today. I think we all have to recognize the importance of AI in our workplace and what the changes are that will happen because of its presence. AI doesn't feel, it isn't a sentient mind or understand like humans, but is actually trained on the data that we provide it. And it's not about AI machines taking over the planet or the workplace. It is not infinite in its capability today. So there are a lot of clear examples of people thinking that this is something that has the power today to develop its own capabilities and continue to evolve without human intervention. I think there's, I think we need to break the misconception of that being the primary, concern about AI. So there's significant benefits and concerns over AI usage, and it's really up to us to use AI in a constructive manner, one that requires great understanding and learning of all of us, frankly, on how to use it and what it is. I love this graph. So what are you looking at here? Well, these are the number of parameters of selected AI models and where generally the human brain lies as far as number of neurons. It's not really an exact match, and I'll talk to that about in a second. But why is AI suddenly here and everywhere, it seems? Well, there was a perfect storm of breakthroughs over the past 5 years that have occurred in generative AI, for example, being open to the public has really increased everybody's familiarity to an extent with AI. The abundance of data that we have today, the universal expansion of cloud systems, the wealth of information on the internet, they have an incredible population of data to train and develop on. To put this in perspective, the volume of publicly available data for AI training has expanded exponentially over the past 5 years. In just the past 5 years, the global data has gone from about 59 zettabytes to 181 zettabytes. So we're seeing exponential growth in the amount of data that's available potentially for AI to utilize. And what's interesting too, I found in some research, is that the set of novel non-synthetic, high-quality data that's accessible publicly for AI training is actually expected to be exhausted by the 2026 to 2032 timeframe. So in the next 5 years, it's expected that we'll actually hit a limit of how much information that it's able to consume and continue to develop on, which is interesting in a public sphere. Computing power has increased, we know that, right? It's grown exponentially as well, doubling approximately every 5 months, which far outpaces what we know as Moore's Law, which projects doubling every 2 years. And then we look at model development and parameters, the learned values within a machine learning model that determine how it maps the input data to outputs, right, here on this chart. Think of parameters as dials or knobs, right? So in an AI model to generate useful outputs. And this has grown exponentially too, as you can see in the graph, from something around 117 million parameters just about 5, 6, 7 years ago to 1.8 trillion now with the just retired GPT-4. And so if you think about this in the human brain context, the brain has approximately 80 billion neurons, somewhat akin to parameters, but it's also important to realize that the brain has 100 trillion synapses. So this is much more similar or akin to what a llama can do from a processing perspective. We also have generative AI breakthroughs. You all saw when ChatGPT rolled out around the 2022 timeframe publicly. The democratization and accessibility of these tools has increased, and the investment and expansion by governments, by private equity, have pushed AI into the forefront. So there are different types and functionality levels of AI. Today we're working with what is called narrow AI, ANI, which is known as weak AI. AI that is specialized in specific tasks or activities. There are two others, general AI, AGI, or strong AI, which is kind of akin to matching human intelligence, which is future and theoretical, and super AI, or what's known as super intelligence, which is speculative today. Applications of AI are wide-ranging, but generally are classified across these 8 areas. We think about machine learning, which learns from data without explicit programming, through deep learning, which is thinking about using disparate data sets and neural networks with multiple content types. There's natural language processing, so the ability to understand human language and respond. Something that's used a lot in our industry is computer vision, which uses and interprets visual information. And then we have things like expert systems that are rule-based decision-making aids or systems that we'll talk a little bit about today. Neural networks around human brain-inspired computer models. Robotics, think about train automation technologies, right? We have that interact with the physical environment and actually could use, like, for example, computer vision as well, so different types together to safely operate a train from a distance without a human operator. And then generative AI, which we seem to hear a lot about today, generating new content, code, text, visual images, etc. So let's talk about AI for freight rail performance. As with any highly operational field, the potential applications of AI in freight railroading is vast, and the potential value is very high. This is especially true when thinking about the criticality of safety in our industry, the positive sides of environmental performance, and rigorous compliance requirements in the field. AI is progressing towards and already used in many areas of freight rail environmental sustainability, resiliency, safety, and compliance. Safety enhancement and training, intrusion detection, locomotive operations and monitoring, incident response, emissions measurement and reporting, greater operational energy management, flood prediction, and disaster response and maintenance, just to name a few. But the picture is not 100% positive for the environment, and we do have to acknowledge that when we're using AI models, we're actually using a lot of resources to do so, right? So I think I read that the human brain uses approximately 20 watts of energy to effectively function, right? But we're seeing data centers today consume a huge amount of energy, and the load on our existing energy infrastructure is large. In fact, it is estimated that by 2030, 10% of all US energy will be consumed by data centers alone, up from 3% today. So that's pretty incredible. And then with that comes the costs associated and also potential water use, et cetera. So to give you a quick sense, and then I'll hand it over to my panelists and case studies, of these actual uses of AI in freight rail environmental performance realm, I collected a couple applications for you to look at today. One example that I know of is Cedar AI's OptiSwitch, which is used for industrial yard operations, effectively taking what it takes somebody to plan a switching plan from about an hour to a few seconds. Though it's not as advanced as, let's say, somebody who's been doing this for 40 years, it can get to an 80 or 90% success and efficiency in those few seconds. So when you think about, for example, new workforce considerations, we're having a lot of retirement of the older generations of railroaders, right? This helps to not only train, but also create a feedback loop for how we actually schedule and switch a yard, as an example. ENSCO is also using artificial intelligence and machine learning to improve rail safety by detecting trespasser hotspots. In fact, FRA has been advancing this in the US DOT crossing lab at TTCI in Pueblo, Colorado. We have deep learning examples, right, where, for example, H2O AI has developed a flood intelligence blueprint that takes into account all the information that is available from USGS and uses technology with NVIDIA to effectively predict where there might be floods, as an example. So impacting bridges or other railroad or linear infrastructure in the environment. We have natural language processing. US DOT just completed a real in-depth assessment of railroad accidents in 2023, looking at a 10-year period from 2009 to 2019. And we're really able to pull out the dominant factors of accidents, right? So everything from human cause factors, which were found to be 35% of all the reported accidents, down to track and roadbed related problems causing 23%, and then other critical factors that were listed in the study were really pulled out by the use of AI and cataloged for the first time. And then finally, I used this example previously, robotics AI. So when we talk about Rio Tinto's Western Australian iron ore operations, they actually use 200 locomotives that are automated to service their mines in the region and run at a grade of automation 4 using automated train operation, ATO, and ETCS level 2 signaling, and the elements of computer vision to basically say that there's something in the track that's fouling the track to automatically stop those locomotives as needed. So since operating on their 1,700 kilometer network since the year 2018, they've estimated over 30% improvement in efficiency and 50% lower emissions, greater safety, and higher asset utilization. So pretty interesting. So I'll now hand it over to my esteemed co-presenters and panelists to actually Dustin Bullard, CEO of PTC Services. Big one.
How y'all doing? So, good morning. Dustin Bullard, Positive Train Control Services CEO. When people hear the term AI, especially in railroad conversation, they go into a lot of different directions. Some people think it's science fiction, robots replacing people, or they think it's just another buzzword. Those are all phase 2 projects for us. So phase 1 is just assistance. But what I want to talk about today is something that's a little simpler and more practical. For us, AI is not about replacing a railroad professional, but augmenting the professionals, such as electricians, mechanics, and technicians who spent years learning how locomotives behave. It's about helping those people get to the right answers faster, more consistently, and with less wasted time. And that's where our AI, Lisa, comes in. So Lisa was built around real operational problems. Locomotives fail, troubleshooting takes too long, and expert knowledge is hard to scale. Lisa helps by analyzing symptoms, organizing technical knowledge, and narrowing likely failure points and guiding a technician towards the best next check. And that's the term that I like to key in on, the best next check, because that's where our downtime lives. The technician runs out of places to go, and we're kind of all just staring at a locomotive for hours or days, right? So in those instances, we're living in uncertainty, trial and error, and time between us figuring out what the locomotive's doing and how to fix it. Every extra hour spent in that gap costs money and creates operational strain, and it keeps assets out of service longer than necessary. From that standpoint of this panel, it also has environmental implications. Waste is not only fuel burn or emissions. Waste also shows up in unnecessary parts replacement, repeated failures, extended downtime, and inefficient use of labor and equipment. So when we talk about AI here, we're not talking about hype, we're just talking about a practical decision support system with high consequences. AI tools are transforming how railroads diagnose failures because they can enable faster, more consistent troubleshooting, reduce reliance on trial and error, and capture expert level knowledge in real time. That's especially important in rail because experience is not always evenly distributed. I don't know how many of you have ever had to troubleshoot a locomotive, right? But if you have to, you get to a point where you need help. So you have to call someone. And that person might be on vacation. They might be in the middle of their own problem. You might only know one good air expert, right? So you're very limited when it comes time to how do we get to these problems? How do we solve these problems? We've done all the troubleshooting guides, right? So sometimes your best expert's not even on site. Sometimes the person's looking for the problem, has the skill but not the years of pattern memory, and Lisa helps close that gap. She doesn't replace judgment, she just supports it. So you can ask the right question, she can get you into the right area that you need to go. And because it's AI, it doesn't take a vacation. Let me give you a real case study. So we had a locomotive that had been down for more than 2 weeks. There had already been multiple unsuccessful troubleshooting attempts, and the problem had been worked, but no true root cause had been detected. So we got called. This is the example of we're trying to reach out to experts, and to be honest, shame on me, I was third on their list, right? So they called their first expert that they always go to, but he wasn't available. They called their second expert, but he's in the middle of something. So they're like, well, what about this guy? So they call me. They call me, I come down, we look at the problem. I'm gonna get a little technical, so I'll apologize. The ASC module is burned up. You can visibly see it. Wires that have been exposed to a lot of heat. And the obvious thing would be, well, we need to replace the ASC module. But their technicians had not ever had a locomotive with EM2000 on it. They were dealing with -2 style systems, and now they've got this computer system in front of them. They call me down, I look at it, I say, well, do you mind if I use my AI? So I asked Lisa, I explained the wire that we found. So the ASC module is burned up, and it was particularly focused on one wire. I gave her the wire, and she immediately tells me to check the diode in the SCR. Like, it was that fast. She said, look for shorted diodes in the SCR. So we did, and there was AC1 diode for the leg 1 was shorted. Now, that's an odd failure for a diode anyway, right? Most times diodes open circuit. So this was an odd failure. Even for me, I wouldn't have got there that quick personally, and I like to think I'm pretty good. We got there, diode shorted, we replaced the diode, we replaced the ASC module, unit operated again. It took me longer to drive down there, 5.5 hours, than to troubleshoot it. We were only on site for 3.5 hours. And part of that was, hi, I'm Dustin, right? I'd love to tell you that was the end of the story. So we fixed the problem. They were able to get the locomotive out and it ran fine for 2 weeks. Then I get a call 2 weeks later. The diode is shorted again. They had it didn't burn the ASC this time, but it did short the diode. So we go back down, and this time I engaged Lisa again. I said, the diode keeps shorting. I still had the chat string with her. So the diode keeps shorting. And she says, check RE3. Almost instantly says, check RE3. So RE3 is part of, and then again, sorry if I get too technical here, your generator, whenever it unloads, you have a GFD contactor that dissipates the current and voltage that's on the generator field through the RE3. So we look at the RE3, and the RE3 is actually blown. You can't see it because it's not out in the front. It's actually behind a panel. So it wouldn't have been the first thing anybody looked at. So we replace RE3, but before we go again, I asked Lisa, why would RE3 blow? It's a 300 watt resistor, right? And she says, the field for the generator might be shorted. And then continues to give me how to check the resistance of the field coil for an AR11. We check the field resistance, and I give her the measurements. She actually said we had to do it under power. You had to provide an actual power source. You couldn't just do it with an ohm meter. You had to give it a power source and calculate it. And she also told us how to calculate the resistance. Also, Ohm's law, which I already knew, but she gave it to us anyway. We calculate the field resistance, and it comes out to 2 field windings and a generator are shorted. The reason that the failure kept happening, now I didn't need Lisa to tell me this, once I knew the field windings were shorted in the RE3, I could put the story together myself. They would trip ground relay for whatever reason. It would immediately drop load, GFD drops, RE3 is blown, the only path it can dissipate through is the diode, shorts the diode, now you have the problem again. So this was only happening, and it felt intermittent to them, but it was consistently the field windings were shorted. As long as you didn't drop load for ground relay or any other reason, the unit would operate fine. So it felt intermittent, but it wasn't. It was just an issue that was too complicated for the mechanics and technicians on site, which is why this AI is super helpful. We expect the technicians and mechanics to do doctoral level research. When it comes time to troubleshoot a problem on a locomotive, they have to go to a service manual, a schematic, another schematic because that one doesn't match, subsystem service manual, subsystem installation guides, and then they got to call somebody. So you've got 6 or 7 reference sources, and we're expecting the guy in the field who's changing the oil to do all of that. That's a lot to expect, right? So I digressed a little from my script, so give me a second to catch up. So in this, we went from 2 or plus weeks downtime to roughly 9 total hours of downtime. And that in the savings and no part swap, no unnecessary part swap, no more fires, no more wires. There's a lot of waste averted there, and the technicians were able to do other work instead of focused on that. So I appreciate the time.
Hi everybody, Simon Davidoff, Grand Crew Consulting. I'll explain maybe another time. There's no time to explain why I'm called the Grand Crew, but it has a link to wine. Nothing to do with today, but that's another story. We've talked about AI having the perception sometimes of being a little science fiction. That's why I also put this picture up, because 20 years ago, many of the pundits were predicting that we'd have flying this and automatic self-driving vehicles and trains and so on. But what I want to talk about is something that's often somewhat overlooked, and it's the back office. Although you could say an operator is front office, but it's something that is somewhat invisible to the public eye. And hopefully you see in this picture something on the left on screen, your left, that isn't like it is today, but it was like that not that far in the past, that an operator would be searching through the correct, or looking for the correct operating procedure at 2 o'clock in the morning when it's times of the essence and needed to get an answer. So is it progress to digitize those paper documents, those SOPs, those contact lists into now PDFs, where you still have to sort of search through electronically using the Control F type of function? You know, is that real progress? I would say not so much. So what this company, Beacon, that I'm presenting a little bit of a story about today, my case study is more around how this solution I'm going to describe was adopted rather than how it's producing results right now. 'Cause as we speak, the client that sort of co-created this solution, Georgia DOT, have gone very public with those accolades, is rolling it out to their main traffic management center in Atlanta, Georgia, with 60 operators as we speak today and tomorrow. So what does this thing do? Why is it progress? Basically, it ingests the SOPs and the contact lists from a short line railroad or a DOT, and it enables the database to be queried using natural language, so that the information coming back to the operator in this very clean sort of interface is the right information at the right time with the right set of contact departments and so on, that is dependent on the type of incident that is now in evidence. So the way to show it is just the screenshot. What it's showing here is, I ask you the question, you know, when should I call this organization? It's a hazmat type of incident. and it surfaces the SOP extract that relates particularly to that incident at the right time. And if you're still not quite sure that, where did it get that information from, can I trust it? And that was one of the words in the title of this presentation. You can click on a button and it will go straight to the document where it found and pulled that information. So it'll give you the citation. And if you're still a little bit wary about what that documentation is telling you to do, the operator can quickly give it a thumbs up or a thumbs down and make a comment. So already you've got a kind of curated feedback loop right there. And I should say also, if the question or the answer that it returns still needs refinement, you can ask another question. So it's almost like having a dialogue with your own SOP network and your own ingested database. So it can't go off on a tangent. It can't sort of scraping the internet for answers. It just looks at the existing SOP infrastructure and contact lists. Speaking of which, it's so funny that when operators were looking at this and adopting this and trialing this solution, one of the benefits that sort of rose to the surface quite quickly is, this guy that you're telling me to contact is left, and that information is not true. So again, quickly, thumbs down, that needs reviewing. And by the way, it doesn't just offer one contact, it would offer several related contacts and departments that need to be involved in this particular incident. But that feedback loop, that simple maintenance of a contact list is something quite powerful, even though it sounds quite simple. So it does a lot more than that. Under the hood, it's got a very strong large language model. It uses generative processes to query in a very intelligent way, but the operators see a very simple outcome, which is the speed of response reduces. So if you've got a safety incident or a hazmat type of incident, and you can deal with it faster, more efficiently, then the benefits are quite evident. And it's summarized on this slide. Also in the background, you've got this feedback loop, as I mentioned, so you can kind of, over time, optimize or even improve the ingested information. You can improve the SOPs and update them and contact lists. And you can also evaluate how well you're doing, so that the system has got all this logged information and can basically track important metrics about clearance time and so on. So it's got an audit trail and maybe an FRA document which could be substantiated, so you can be compliant to the safety regulations and your own processes in a very transparent way. So now you've got some success with a major client. So that's the DOT, the traffic world, and there's a quote there from the deputy engineer. So somewhat being proven in that world, but the logic now is that clearly the use case is similar in transit. I put up an example there of a rail control system RFP by TriMet in Portland just a few weeks ago, and they added in as a priced option for exactly this system. They termed it an AI-enabled SOP assistant. So it's kind of validated in the transit world. Now the question is, and our research shows, that no surprise that the challenges in the railroad industry are not dissimilar to transit and traffic. And that little graphic on your right shows a small study that we did with the help of AI, comparing planned response processes and documents and procedures that's kindly supplied by Jason. Norfolk Southern's information is in there. And you can see that there's a distinct overlap of what this does today and what the railroads clearly need. It's a very similar use case. So that would be my sort of last message really, is that in this world, could it be that railroad, it's called Traffic Management React, now is it Railroad React? You tell me. I think it could be. The evidence seems to point in the same direction. So my message would be start by starting, prove it. You can do it in 60, 90 days. It sounds simple in essence, but it's a very effective and powerful way of making a difference to those stressed out operators at 2 o'clock in the morning. Thanks.
Dan DeVoe, Director of Marketing at RailState. For those who don't know, RailState is a rail data provider. Our aim is to independently measure everything that is moving across the entire rail network. And to do that, and critically to do it independently, aspects of artificial intelligence have been built into our DNA as a company. So what I'm going to share today is more about how we work and how we use AI to turn photographs of trains into useful intelligence for operators, and then also how we are expanding the use of agentic AI to develop further insights from a vast data set that we've been collecting over the past 5 years. So first, how RailState works. So again, we set out to gather data on every train moving across North America. And it's a core philosophy of our company that this data needs to be independently gathered, not subject to any restrictions from any railway or any other party. So that means we have to be collecting the data outside of the right-of-way. So what we do is we install cameras on properties outside the right-of-way, but along rail lines, and we have agreements with property owners to host the cameras. We have about 310 right now across Canada and the US, and we're adding about 12 a month currently. Plan to increase that pace shortly. The cameras, which you see up in that round circle there, they have infrared illuminators, so they're able to illuminate a train at night without using any visible light, so there's no disruptions to anyone in the area. And then as a train passes the camera, we take 10 images a second of each train. So depending on the length of the train and how quickly it's moving, that can work out to a couple thousand images of an individual train. Then we stitch those together, and then this is where AI comes in. So we stitch the images together and create a full panoramic of the train. And then we have machine learning algorithms do what a human could do, but not at this level of scale. So what we're doing is reading what is available on the outside of the train. So every rail car, locomotive, that means we're getting the locomotive owner, locomotive number, the car types, the car IDs, container types, container IDs, hazardous material placards, things like the length of the train and the speed at which the train is moving. And with all of that, we then create a full consist of every train that we capture, and that data is available to customers in less than 30 minutes from when a train passes. And here is a bit of this operation in more detail. So we have an image here of a tank car. This one is carrying diesel fuel, so UN 1202. But from that observation, that image, we are creating structured data. So that, again, the type of car, the car number, the capacity, the location of this car on the train consist, the exact timing of the sighting, and the specific locations of the sighting. So this information is something that obviously the railroad can have, and parties to a waybill may have. But other than that, it's been this type of data has been unavailable to any other parties. So that again gets back to this level of independence that we're trying to provide. And think of how this data can be used, since we are in the environmental section this morning. Hazardous materials came up as a potential thing to discuss. So it is really important to know exactly what is on your property and having the knowledge to be prepared for any of the potential risks. So generally, short lines are on the receiving end of Class 1 information. You're told what's coming, what's on the train. Most of the time that works fine, but when what actually arrives doesn't match what you've been told. It's the wrong car, an unexpected hazmat, missing equipment. Resolving that discrepancy can be challenging, especially when the first option is to check the records that have already been determined, to be incorrect. But with RailState and that photographic evidence, you have that proof of, this car was seen at this place at this time, and here is the documented proof of that. It can also extend to the condition of the car. So, maybe a ladder has been ripped off or a door has been mangled. Knowing the truth of the matter and having the evidence of that, and where something did not, something did not occur versus maybe where it did occur, can be useful in dealing with any of those disputes that you may have. Now, on to something that we as a company have been increasingly using to extract insights from a data set that we have now that is 5 years in the making with billions of records. Want to know how we can better understand the data to answer some of those harder questions about what's really happening on the network. So this is where agentic AI comes in. So agents that are trained to understand the data structure and also the structure of the rail network. And so with a natural language question, so in this case, ask the agent to provide a summary of changes in hazardous material flows on a particular corridor in Oregon. So the agent pulled the relevant records from the RailState API, identified patterns across the full year of traffic, flagged the material changes in the commodity movements, built a summary table, generated the written analysis, and produced this, this structured output all within a matter of minutes, all on its own. So this is something that from maybe an emergency planner, a short line operator, a planning firm, state agency, port authority, anyone who needs to understand what hazardous materials are actually moving on a specific corridor, they can ask a question in plain language and receive a structured analytical answer within minutes. Of course, there are many things because we are capturing information about every train that we see. The applications go far beyond looking at hazardous material flows. But what I wanted to share is that this is what can happen when AI is connected to the right data. This is not a chatbot, it's not just a demo. This is a real reasoning engine working against real data set that's continuously updated and produces the kind of operational intelligence that I think can show what could be possible in this industry. And for us at RailState, it is a very exciting time for these types of applications. And I think that's it. Look forward to some questions.
All right, thank you, gentlemen. Very much appreciated your experiences and insights. I'm not offering much here except to take some questions and ask some questions. One of the things that I really took out of the presentation was the need for a digital data set. I think historically we've often had hard copies, binders, locomotive schematics as old bed sheets or printouts. And so the need to have a good digital data set that's both clean and up to date to give the AI the information that it needs in order to make the suggestions that we want. And the other aspect of it is just like, a lot of this is it's going to be about how you manage the machine-human interface if you think of the AI as the machine. And and training your staff how to ask the right questions to make sure that they can get the information out of the AI that's necessary. We will be taking questions from the floor. If anybody has any, please step up to the mic, introduce yourself, and then ask your questions. Is anyone interested? I also have some questions to ask our panelists. No, nothing yet? Okay. All right, let me see, where's my first question for Dustin, to start with. From a CMO's perspective, we know that AI thrives on organizing large, disparate data sets. For a small short line with limited IT infrastructure, what's the first practical step to begin collecting the clean data that these systems require?
What we would want is a schematic that closely resembles the locomotives that they're using. So just as a small example, we recently were doing installs on Jeep 9s, and the schematic was a very clean schematic, but it was not like the locomotive at all. So even in those cases, if the schematic does not match the locomotive, we can still adapt LISA because we can take pieces from other circuits that the locomotive does match and recreate the same fault tracing steps.
Okay, thank you. So you're saying the data needs to represent reality?
Correct.
In short. All right, thank you. All right, and for Simon, you showed how Beacon surfaces SOPs, contacts, and audit trails during high-stress incidents. When we think about rail hazmat response, where does delay pose the greatest environmental risks?
Well, I want to be cognizant that I'm not an environmental expert, so there is that. So I don't know if I can rank where it makes the worst case or the worst impact or the most serious impact. But I can say that responding quicker, more efficiently, clearing up an incident faster, by definition, will reduce the environmental impact, or it should do. I would also say that the underlying risk is that the SOPs and the procedures and so on of being outdated is actually a more serious risk than the risk of delay, so to speak. So I think the two go in hand. If you can fix the delay and speed, but you have to operate on correct information, and having a feedback mechanism to do that is very valuable.
Okay, thank you. And Dan, you mentioned that this was your favorite question. There's a lot of talk about AI replacing workers. In your experience, has the reality been closer to replacement or augmentation?
So far at RailState, has not replaced workers in any way. It has certainly augmented many roles at the company. So from things that I do on the marketing side, or things that any of our team does looking at data, they're able to do significantly more and significantly faster than they were previously. One thing that we have found, though, and again, we have not replaced anyone or let anyone go for these reasons, but it has changed our hiring outlook. So we are looking at different types of roles and individuals than we were 6 months ago. And again, if you asked me 6 months ago, what for the next year, what types of roles are we going to need, I would have had an answer back then, and now it's completely different. And with the pace of the evolution and development of these tools, that is just sort of increasing. And I think next week I could have a different view of what type of role would be
target
most critical. Yeah.
All right. Anyone have any questions in response, or should I carry on?
I guess I have a question.
Okay, please go ahead. Introduce yourself.
Hi, I'm Christian Milton Davis. I work at the Belt Railway of Chicago as the PTC manager. And what I've noticed is I've come into a position where we have our PTC safety plans, our implementation plans, and when I alter one section of a safety plan, oh no, Christian, there are 12 other things down the line that need to get looked at as well. So as far as you guys' program goes, and maybe for Beacon, the program that you spoke about earlier,
Yeah.
has that been used as a way to update SOPs as well as guide people to show, all right, you tweak the dial here, 13 miles down the line, you have to update that as well. Have you noticed that change too, or are you mainly localized to the exact problem in front of you?
No, it's a great question.
Good question, Christian. Yeah, thank you.
By definition, the beacon system does do what you're describing because it ingests a whole raft of different documents that are in that sphere of knowledge. But it's the operators that spot the errors, and providing the operator with a quick feedback mechanism is logged already. So when the review of all those logged comments comes through, it has a kind of summary result of several documents being needed to be updated. Because if you remember, the AI is intelligent enough to query the SOP based on the particular type and time of event. So if there's something missing, it'll show up because operators will say there's something missing, it's not quite right here. So you can use it as a stimulus to update documents, but it won't tell you how to, and it's not meant to. Yeah.
Thank you.
And go ahead.
Hi, I'm Bridget Dean with Progressive Railroading, and Dustin and Simon, you both mentioned how your programs can help with onboarding or with people who don't have as much experience. How do you, or what do you worry about when it comes to expertise, and how do you aim to keep that expertise when it's not being used in that sense?
Well,
Thank you.
one thing that's happening in the rail industry now is your expertise is on the edge of leaving the industry. So when that expert retires, his knowledge goes with him. Something, at least in the maintenance sector of the rail industry, Lisa can bridge that gap because that knowledge doesn't leave her and it's completely accessible to the next technician. The other thing that is actually really good with her is that the amount of information that she has in her with regards to maintenance, you don't have to just be troubleshooting. You could ask a generic question like, what is the GR relay for, right? And she can do on-the-spot training in an environment where it makes sense, as opposed to like in a classroom where they're dumped a bunch of knowledge that they might not use. So I think it can be used in that manner.
One of the points that I think is interesting is how you then start to collect and continue to build upon the knowledge that is innate in the organization. Maybe Simon, you can talk about how tools like yours enable that kind of buildup of knowledge over time.
Yeah, I was going to add to Dustin's comment. The fact that the solution surfaces a step-by-step guide of SOP says this, do this, this, and this in a sequence. It's almost like a training aid in itself. So you could imagine a fairly inexperienced or junior operator being able to almost act as a more experienced operator based on this guidance and this assistance it's being given, or he or she's being given. One of the things that Georgia DOT operators have mentioned is to provide a kind of checklist. So it's going a little bit step further. Just got to be careful that we don't project what should be done outside of what the SOP is saying should be done. It's really like an orchestration of the knowledge to help onboard people, train people, and manage the optimization of those processes.
Thank you.
Thanks.
All right, I have one more question, just for all the panelists to interact with. So with the presentation clarifying that AI is a decision-making aid rather than a sentient mind, how do you manage the trust gap, either when seasoned railroaders are asked to rely on an algorithm instead of their traditional instincts and knowledge, or if you're working with younger people who, like some of my own children, who are deeply skeptical of AI? How do you manage that gap? Yeah, why don't you start, Dustin?
Have you ever heard of the sentence, the quick brown fox jumps over the lazy dog's back? So they used to use that to test typewriters. I used to use it to test the screen on a radar. We would put it has all the letters in the alphabet in it, and we could look at every letter in the alphabet through that one sentence and make sure that no letter was skewed. And if they were, we had a particular alignment we needed to do. We have a very similar process with Lisa, where we have a battery of questions that we have predetermined responses. So as we make adjustments to her, we go back through the battery of questions and make sure that she gives us a response similar to what we're expecting. And if not, we have proper alignment that needs to happen, right, in those questions.
Thank you. Go ahead, Simon.
I don't know if I can really add to that. I think I'm maybe repeating myself that you trust it because when it's surfacing the information, it's surfaced it from a known data set. It can't go outside of its sandbox. And if you still are not sure that there's something it's telling you, it's because the base data is wrong, not because it's hallucinating, because I think that's where you're going.
Right.
Yeah.
Well, I'm thinking more about like just, the instinct of an older employee with lots of experience is, well, I know what I'm doing. So how do you get beyond that? Like, no, you should be looking at this.
Yeah. It's an adoption topic. Back in my former AECOM days, I met this quite strongly, that where do I put my engineer's stamp? This is an electronic system. How do I overcome that?
Yeah.
The only way to overcome it really is just trying it and piloting it, and step by step, slow baby steps, and proving its value quickly.
Yeah.
And the confidence builds that way.
Okay. Thank you. Dan?
For us, what we often do is, check against the raw data. So if AI is doing some analysis, we're able to check it against our raw data with someone who's experienced as an analyst. We have those checks, but also I think for us, I guess we don't have as many potential pitfalls as some of these other tools. Not the tools, but getting things wrong in maintenance or in hazmat response comes with a different risk than looking at train flows on a corridor.
Thank you. Jason, do you have any final comments? No? All right. Well, thank you for your time and for joining us for this. Thank you to the panelists. Very much appreciate your time and the interactions we've had over the last few weeks.
Thank you
Thank
for
you.
having us.
Thank you.